Today we're going to look at solving multi-step equations, and we want to start with some vocabulary. An equation is a mathematical statement that two expressions are equivalent. The solution to an equation is the value or values of the variable that make the equation true. A linear equation in one variable can be written in the form a times x plus b, where a and b are constants and a is not equal to 0. And the steps for solving equations. Now, when I solve multi-step equations, I use 5 basic steps. Step number 1 is to clear all fractions, and you're going to do that by multiplying every term in the equation by the least common denominator. Step number 2 is to clear our grouping symbols. We will use the distributive property to do that. Step number 3 is to simplify each side, which means to collect terms on each side of the equal sign, and to do that I will be adding. Step number 4 is to isolate the variable. Notice my step 4 says to put the variable on the left. It doesn't matter, I prefer it on the left. And if all 4 steps have been followed, then step number 5 is to solve, and to do that you will divide. And I always think it's a good idea to check. And when we're solving equations, we run across 2 special cases, and both the cases are going to occur after step 4 or during step 4. The first case is called an identity, and in step number 4, when I go to isolate the variable, my variable is going to cancel, and so I'm left with 2 constant terms. If that constant term is equal to itself, then I have an identity, and that indicates that my equation has infinitely many solutions. Or in step number 4, I have a contradiction, which is a statement like 1 equals 3, negative 2 equals 9, a statement that is never true, which indicates no solution. Now let's look at some examples. In example number 1, I have grouping symbols on both sides of the equation, but I always go through my steps. So step number 1 is to clear all fractions. I have no fractions, so I'm going to skip that step. And then step number 2, I have parentheses, so I'm going to use the distributive property. It's 34 minus 10x equals 6x plus 2. So I've completed step number 2. Step number 3 says to simplify each side, and as you can tell, each side is already simplified. I have 1 constant term on the left, 1 variable term on the left. I have 1 constant term on the right, 1 variable term on the right. So I can skip step 3. Step number 4 says to isolate the variable. To do that, I'm going to subtract 6x from both sides, and I'm going to subtract 34 from both sides. When I do that, I get negative 16x equals negative 32. So I'm at step number 5, which means I'm going to divide. And I always divide by the coefficient in front of my x term. So I have x is equal to positive 2. You want to plug that back in for x into the variable. So I have 7 times 2, which is 14. Put 2 over here. I have 7 in parentheses times 2, which is 14. Those 2 are equal. Therefore, x is equal to 2. In my next example, I have some fractions, and I also have grouping symbols. So if I have fractions and grouping symbols, I tend to switch step 2 and step 1. So I'm actually going to distribute first, and then I'm going to declare my fractions. So I'm going to multiply 3/14 times 1x, and I'm going to get 3x over 14. I'm going to multiply 3/14 times a negative 4, and I'm going to get a negative 12 over 14. And that's going to equal, I'm going to multiply 3/7 times x, and that's going to give me 3x over 7. And I'm going to multiply 3/7 times 1, and I'm going to get plus 3 over 7. And now that I've cleared all grouping symbols, I'm going to go back and I'm going to clear all fractions. Now my least common denominator is 14, so I am going to multiply every term by 14. And when I multiply 14 times 3/14, I get 3x. When I multiply 14 times 12 over 14, I get minus 12. Equals, when I multiply 14 times 3/7, I get 6. And I keep the variable. And when I multiply 14 times 3/7, I get 6. Alright, now I'm at step number 3, which means to collect like terms. Again, each side is already simplified, so I'm at step 4, which means I'm going to put my variable on the left. So I'm going to subtract 6x, and I'm going to add 12. I'm left with negative 3x equals positive 18. I'm going to divide both sides, which is step number 5, by negative 3. And I'm left with x equals negative 6. And at this point you can plug it back into check. I put negative 6 in for x on the left side. I get negative 30 over 14. I simplify that. I get negative 15 over 7. I put negative 6 on the right side. I get negative 5 times 3/7, which is negative 15 over 7. So I know that my solution is x equals negative 6. Example number 3. There are no fractions, so now I'm going to click grouping symbols. I'm going to distribute. I get 3x. I'm going to distribute plus 6 equals 3x plus 6. Now at this point I can see that it's an identity, or even if I go to move my variable to the left, I'm going to subtract 3x. I move my 6 to the right, which is minus 6. Those cancel. I'm left with 0 on the left side. These cancel. I'm left with 0 on the right side. And there's an example of my identity, which means it doesn't matter what number I put in for x, I'm going to get a true statement. And let's look at one more example. Okay, there are no fractions, there are no grouping symbols, and now I do need to do step number 3, because on the right side I have 2 variables, so I need to add those together. So I have 2x equals 2x plus 1. And now I'm going to do step 4 and isolate the variables. So I'm going to subtract 2x. And I discover that these cancel out and I'm left with 0 on the left. But I have a 1 on the right. Is 0 equal to 1? The answer to that is no. Therefore, there is no solution, because this is a contradiction. We're going to look at some more examples in class. I hope you took good notes. If you need to go back and play the video, you're free to do so. Thanks.